So pretty much for this video, we're going to be talking about simple harmonic motion. I'll just talk a little bit about Hooke's law, especially about periods and the equation for that, and then we'll talk about example problem number 33. So we'll start out just by just this is something you should write down and know. Hooke's law. Just the force of a spring. So force of a spring equals negative kx, where x is the displacement of the spring and k is the spring constant. So that's just something you should write down real quick. Now we're going to talk about the period of a spring. So whether it be, the spring can be just like this, like that, or downwards, but the period of a spring is how long it takes for the spring to go down and come back into place. So the spring will go down, then come back up, and then come back into place. So for that, we can use the equation T, which is equal to period, equals 2 pi times the square root of m over k, which is mass over mass over spring constant. Okay, so now we're gonna move on to the problem here. So an object is initially hanging in equilibrium from a vertical spring. The object is pulled down 15 centimeters from its equilibrium position, as illustrated above, and released at time t equals 0. The object then oscillates with a period of 2 seconds. Let S be x equals 0 be the equilibrium position, and let the positive direction be upward. So for this problem, we're going to look at 33. So what is the position of the object at t equals 3 seconds? So now for number 33, we just read it. So it's asking what the position is after 3 seconds, and the period is 2 seconds. So we can just visualize it here. So if it's released where it's pulled down by 15, so this is x equals 15, x equals 0. We know however far it's pulled down here, it's gonna go up that way, compress, and then come back down. So the first second it's gonna go all the way up. Second it's gonna go all the way down because the period's 2. So it goes up to x equals negative 15, back down to x equals it starts at x equals negative 15, then goes up to x equals positive 15, back down to x equals negative 15. So that's after t equals 2 seconds, and then of course it's going to go back up to x equals positive 15. at the third second. So we can look on our equation sheet, on our answer sheet, and we see, oh, A, that makes sense. It's right there. So that's our answer.